pages opened up.
No, you're fine.
We've got like 17 different pages opened up right now. Okay. ANOVA, according to William Butler Yeats, she is the Gaelic muse, for she gives inspiration to those who persecutes. The Gaelic poet die young, for she is restless and will not let them remain long on earth. Am I saying that right?
Mm-hmm.
One study designed to investigate this issue examined the age of death for writers from different cultures and genders. Three categories of writers examined were novelists, poets, nonfiction writers. The ages at death for female writers in these categories in North America are given on the womenpoet.xls data. You would like to determine if the mean age at death is different from any categories of writers. Use a 0.05 level of significance. What is the research question?
So it's, is the mean age at death for these women different from any other categories of writers?
Yeah.
And then it states a null and alternative hypothesis. And so for ANOVA, the null is always, the means are all equal.
Mm-hmm.
And then the alternative is one or more of the means differ from the others.
Yes.
Collect the data. Describe the data collection procedures.
Didn't really say any of them, did it? Besides the fact that they got them from North America.
Yeah. So I mean, I'm guessing we would just like have a random sample, but it never said that they did anything.
Yeah.
It just says it was like death for females.
Mm-hmm.
Okay.
Describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data. Students should...
Can you guys still hear me?
Yes.
Okay. I finally figured out how to set up SPSS on my computer. So I switched over and I just want to make sure it's working.
Nice.
Way to go.
I know. I did it by myself too.
Oh, wow. Impressive.
Big deal.
right there. There's Excel one. I wish you could spread these out so I didn't have to, it wouldn't be tough to want to spread on it. I click on both of them, eventually. Okay, I did it in Excel and I got it using the ANOVA. So the mean for novels is 71.448, standard deviation 13.052, N is 67. For poems, the mean is 63.188, standard deviation 17.297, N equals 32. Variable 3 is nonfiction 76.875, standard deviation 14.097, and there's 24 of them.
Right.
Sweet.
What type of hypothesis test is appropriate?
There would be another way.
Yeah. For several means. Are the data, are the requirements meant for this test? So this is where we have to make Q and Q plot if they're not over 30, right?
Mm-hmm.
So variables 1 and 2 are both over 30, so they're just assumed to be normal. So then for variable 3, we have to make a Q and Q plot.
Mm-hmm.
Do you know how to do that?
Don't you just go to the, like, analyze descript, no, the legacy dialog?
Yeah, you can do it on SPSS, but you can also do it on Excel. If you do it on Excel, you just copy the data. You open up the quantitative descriptive statistics,
Mm-hmm.
and then you go to Q and Q plots on the bottom, and then just paste your data in there, and then a Q and Q plot will be made.
Sounds easy enough.
But this one doesn't look very normal.
And all over the place.
What are the requirements? Do we have to have that to be normal?
And the variances have to be equal.
Okay. okay. The variance we just have to check to see if the standard deviation is doubled, right?
Mhm.
If the largest one is doubled than the smallest one.
Yeah.
And it is not. So the variance is equal. So it doesn't really say anything on the answer thing about it not being normal, even though the third one's not very normal.
Yeah.
The test statistic is F equals 6.563.
Yeah.
And the degrees of freedom.
Or 120 within the groups.
Mhm. That's what I got. And then compute the p-value to the alpha level.
0.002.
Yeah. But you don't double it, correct?
No.
Oh, okay, yeah. In the answer key, it says 0.002.
Did it say something in the reading about doubling it?
Let me see. It says p-value in the area on the right is, well, the p-value is always an area in the right tail, and you never divide. So I meant you divide. Usually, right?
The only time you divide, I think, is if you have the alternative hypothesis that is not equal to, and you, like on that one that we missed last week, where we couldn't figure out, I don't remember what question it was. It was talking about if the p-value, let me find the question. This is the one that me and you worked on when Cambry was gone.
Mm-hmm.
I found out what we did wrong. I'm trying to find it. Okay, so it said the probability of being greater than 2 is 0.403. Use the alternative hypothesis.
Mm-hmm.
And the alternative was that it wasn't equal to. So that one you would double it because we were testing first before if it was just greater than.
Yeah.
But if it's not equal to, you double it because then it's greater than or less than. Does that make sense?
Mm-hmm.
Okay. Sorry, I don't know if I worded that weird.
Okay. Make a decision. Do you reject the null hypothesis or fail to reject it? When we reject it because it's less than 0.05 and we're trying to see if it's greater.
Yeah, we reject it. Sufficient evidence. To say that one of the groups is different from the rest.
Mm-hmm.
Down.
Sure. Further study, we find the poets die either earlier than the novelists and nonfiction writers. What significance can you conclude from this?
Don't be a poet.
Yeah. Don't be sad and write poetry.
Poets think too hard about what they're writing, and it causes their brain to die. What's it mean? I don't know.
That's what I would say.
Just a little more stressful.
I don't know
or
if
something?
there's.
Or is
Yeah.
it?
Yeah, maybe stressed or more focused on holding on to those negative emotions.
Yeah.
Something like that. Works for me.
Yeah. Not very deep, so.
All right. You ready to start the group quiz?
Mhm.
In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. That's true.
True. What requirements need to be checked when performing an ANOVA hypothesis test? Sample means are all positive, data in each group are normally distributed, variances are equal in each group, none of the above, or B and C.
Would it be B and C?
I think it's B and C.
That confuses me too because on there it says that, oh, that's for F distribution. Never mind. Okay, to check if each group is normally distributed, do the following. Construct a scatter plot of the data in each group, construct a histogram of all the data, or construct a QQ plot.
Yeah, QQ.
We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest sampled standard deviation is less than 2 times the smallest sample standard deviation. The largest sample mean is less than 2 times the smallest sample mean, or each group has the same sample size.
Should be B.
The largest sample standard deviation.
An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? One, 2, 1, 3, 2, 3.
Four,
So it's going to be 1, 4,
4.
3, 4.
2.
Okay, I gotta write this down.
Yeah.
He's gonna. All right. So we got 1, 4, 1, 3, 1, 2.
1, 1. Yeah, 1, 1. Do 1.
No.
Okay.
6.
And then you got 4, 3, 4, 2. And then 2, 3. I think it is 6.
Yeah.
3 goes. Yeah, should be 6.
Okay. The Socrates data has 6 groups, A, B, C, D, E, SOCs. These data can be found in the wiki. Load all 6 samples into the quantitative inference procedures spreadsheet, or perform an ANOVA test in SPSS and observe that the p-value is 0.0809. Remove the SOCs data. What is the p-value?
doing here because it sucks.
Yeah, I don't do silks.
Hmm?
Yeah.
You don't do six?
You don't have to because there's remove it for the p-value. Can you put them in?
Oh, I just want you.
Yeah, I just want to see what it does. Just to make sure I'm doing it right. 0.08.
Okay, so I got 0.309.
Me too.
The p-value always goes up when only one group is removed compared to the p-value when all 6 samples are included.
It goes down, doesn't it?
Well, this time it went up.
Oh, it did. Okay, and then I guess that would be true.
I don't know. I don't.
Does that mean it always does that?
Yeah, I don't know. But would it always do that?
Okay, I didn't read anything that said it always did that.
Neither did I.
But they always put always.
I know, it makes it a tricky question.
The p-value always goes up when only one group is removed compared to the p-value when all the 6 samples are. I don't remember reading anything about that.
So it makes you want to say yes, but what?
I'm gonna try something. Here's the p-value. Craig Johnson. So p-value is 0.34. I think it's false.
Because Chase just did it.
I just put a bunch of random numbers in there, and then I erased 6, and it went up.
Okay.
Which means it doesn't always go up.
Yeah, excuse me, it went down. Excuse me.
Okay.
Oh, I guess what we could have done is just do it with this. Dang it.
So good. It's gonna be always good. What are you doing?
I was trying to do Control Z. Dang it. It sucks.
What?
I do already put all that stuff in now.
Just hit undo, 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 undo.
That's what Control Z does.
Oh, well then just hit undo. Okay. Okay, what is the highest p-value you see when removing only one group? You will need to compute an ANOVA for each possible option.
So when we remove variable 6, it's the 0.309.
Mm-hmm. When we remove 5.2, no, that's wrong.
Variable 4 is 0.0309.
So it's still the highest, right?
Variable,
Variable 5.
variable 5 is 0.050. Ooh, variable 3 is 0.447.
Variable 3 so far.
Variable 2 is 0.052.
So it's 3.
Is it asking for what the p-value is? Yeah. So it's variable 3. .448.
When all 6 samples are used, what is the minimum or smallest standard deviation?
.216.
And then what is the largest?
.291. The test for equivariance is satisfied for these data. That's true.
Okay. Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plot.
No. Variable 1 doesn't look very normal. Neither does variable 2. Just want to check to make sure they're not all. Yeah, if they're all bad, I'll be suspicious there. Yeah, it's false. I think they all look pretty.
They look pretty normal.
Yeah, they're not normal.
Okay. So that would be false.
Yeah.
Okay, so
Yes. Oh, so go ahead.
oh, sorry. You can go ahead.
You go ahead.
I was just talking about the next question.
Oh, that's what I was gonna do.
Okay. The t statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left? So for the F statistic, I got 2.020, and then the p-value is 0.081. So wouldn't it be to the left?
Um. Yeah, I would think so.
No, I think
So we're saying to the left.
wait, I think it's the right.
Weird.
So 14 is really true, and 15 is to the right.
Okay.
That's weird because when I'm doing those Q and Q plots, they're all. Oh, I see what we did wrong. Oh, yeah. Okay. So when you do the descriptive statistics on Excel, you have to sort it from low to high. That's what normal. Once I did that, they were all normal. Okay. Would it be possible if we met tomorrow? Excuse me, to go over the group meeting? It's just a review.
Yeah.
Would that be okay?
Mhm.
Sweet.
Okay, then tomorrow at 7:30.
Yeah, tomorrow at 7:30.
Okay. I'll see you guys then.
Sounds good.
Yeah.
Bye.